So back in part 1, we saw how to run the hole filling and library optimization application to fill the holes of a library with a diverse set of structures. Here in part 2, we'll go about verifying those results. So now in this project we have a few more views, covering the entire pool of structures, i.e. 1,000 structures from the original library, library 1, and 5,000 structures from the external library, library 2. We also have the original library with the diverse 1,000 structures, and we have the original library with a random set of 1,000 structures. We are now going to use these views to help with the various verification methods. The first of which is to run the self-organizing map application to verify holes were actually filled. And to start that, we first need a self-organizing map of the entire pool to use as a reference for doing comparisons. So let's begin. So we'll go to Applications, Self-Organizing Maps. We'll use a save view corresponding to the entire pool of structures, and we'll use binary fingerprints for the X variable. We'll edit the result name to reflect that this was built on the entire pool, and we'll also increase the dimension slightly to 16 by 16 for a larger map. All other settings we'll leave as default, and we'll click Create Map. After the map is created, we can right-click and view it. Now the important step here is to color the map by cell population and change the max value per cell to 1 and the minimum color to white. That way it will be easier to distinguish the holes in the library and gain a better overview of the map. So there, now you can see that even with the entire pool of 6,000 structures, there are still a few holes, but overall it's a fairly good coverage of diversity. We'll take a mental image of this map for now, but if you wanted to save the image, just head up to File and then Save Image. Now that we have a reference self-organizing map of the entire pool, we can apply it to the original library as well as to the updated library to see how they compare. So let's head back to Application, Self-Organizing Map. We'll change the dataset to Save View and choose Library 1 for the original library. The map is based on fingerprints, and the important step here is that we're applying the map generated previously from the entire pool of structures. We'll edit the result name to reflect that this is based on Library 1. Then we'll click Apply Map. Again, we'll change the settings just like we did for the previous map. And now it's fairly clear that compared to the entire pool of structures we generated previously, the original library of 1,000, Library 1, has a lot of holes. Clearly not as structurally diverse. Okay, now let's apply the self-organizing map onto the updated library of 2,000 structures to see how well the hole filling and library optimization application performed at filling these holes with only an additional 1,000 structures. Again, we'll head up to Application and then Self-Organizing Map. This time we'll choose Library 1 with the diverse 1,000 structures. And just like before, apply the map from the entire pool. We'll call it Library Diverse, and then apply the map. And once again, use the same coloring settings as before. Alright, so definitely more red here. Clearly with only 1,000 additional structures, we were able to strategically fill in many of the holes in the original library, Library 1. Alright, so here's the overview of what we wanted to achieve, but now we can replace these images with actual self-organizing maps to get a more accurate picture of things. We started with a library of 1,000 structures. We then used the hole filling and library optimization application to fill these structural gaps or holes with 1,000 structures from the larger library of 5,000. That gave us a library of 2,000 structures that were structurally diverse as the entire pool of structures, as you can see down here, but with only 1/3 of the number of structures. We'll now go through the library comparison application to further verify the diversity of the structures chosen by the hole filling and library optimization application, and that it was better than simply choosing a random 1000 structures. So the aim now is to generate two histograms of diversity, one that compares the structures of the original library, library 1, against the diverse 1000 structures chosen by the hole filling application, and the other histogram that compares the structures of the original library, library 1, against a random set of 1000 structures. Then we can directly compare the two histograms to assess the diversity. Alright, so first things first, we'll just restore the view so that all the structures available are in the table. And then we'll head up to Applications, Library Comparison. Okay, so now we'll edit the result name and say Library 1 versus Diverse 1000. The reference library will be the original library, library 1, and we'll compare it to the diverse 1000 structures chosen by hole filling. We'll keep the default settings and then click Compare Libraries. Now, while that runs in the background, we'll just do the exact same thing, but this time library 1 versus random 1000. Okay, so as they finish, we'll just incorporate the results into the master view. And then we'll plot the histogram with max similarity on the x-axis. We'll also adjust the bar settings to make it go from 0 to 1. And then we'll do the same for the other library comparison. Okay, so here we have it. The left clearly shows a greater proportion of structures with low similarity values. In other words, it shows a greater proportion of dissimilar structures between the original library, library 1, and the 1000 structures chosen from the hole filling application. But on the right, you'll notice that when you perform a random selection of 1000 structures, you still pick up structures that are similar to what you already have in your original library. And that is evident with the bars to the right that are, say, greater than 0.6 similarity. Now, the last method for verifying diversity would be to run the Scaffold decomposition application on the structures selected by hole filling and compare them to the structures that were selected at random. Now, I've covered Scaffold decomposition in another tutorial, but the results you would expect to look something like this. The 1000 structures chosen by hole filling application contain 1684 unique scaffolds, while the random selection of 1000 structures gives you only 1204 unique scaffolds. So in summary, the hole filling and library optimization application from within Canvas is incredibly useful in managing and updating libraries to ensure that they are diverse, without holes, and contain an optimal set of properties. You can confirm this by running various other applications like self-organizing maps, library comparison, or scaffold decomposition. For more information on the various applications showcased in this tutorial, please refer to the Canvas user manual or contact help@schrodinger.com. If you are new to the Schrodinger suite and would like to gain access to these and various other cheminformatic applications from within Canvas, please contact info@schrodinger.com or visit www.schrodinger.com.